what has happened to the lake to make it so unresponsive to water right now? The fact that it just keeps shrinking and shrinking and shrinking. That story really starts about 100 years ago, where we started doing lots of water diversions upstream from the lake. So it is this basin. And if you use water in the top of the watershed, it doesn't trickle down and make it to the bottom. So the less water we use upstream, the more that will make it down into Great Salt Lake. And so we started diversions for agriculture, diversions to build houses. More people started living in the valley, and we started taking more of the water before it makes its way to Great Salt Lake. And so we got very water hungry, and maybe we even started using too much water. We water our lawns and make them green, and that isn't really good to do in a desert environment. And so if we can save water, we can put some more of that back into the basin and bring some more water to Great Salt Lake. So we've put ourselves in this position of the lake being a little more fragile than it should be because we've sucked so much water from the watershed. Now we meet the pressures of climate change. So now we're starting to see a shift in our precipitation. We're not getting as much snow. We're getting a little more rain than snow. And that rain will just wash off the top of the soil and evaporate. It won't be this nice snowpack that slowly melts in the spring that brings the water to the bottom of the lake. So that's a problem, the shift in the type of precipitation. The other thing that is a problem is the warming temperatures. We're starting to experience these really, really warm summers, and maybe unseasonably warm in the spring or the fall sometimes. Those warm temperatures also bring about more evaporation. And when you get more evaporation and more water that runs on the surface, you're not recharging the groundwater. If you don't get some water down to the aquifers, then the ground is thirsty. So now when you finally do get some good precipitation, let's say we got a really good snowpack this year. If we do, what happens is that water has to fill up the groundwater aquifers and the reservoirs upstream, and still no water makes it to the lake. So we've really set ourselves up for failure by doing all of these water diversions. And I think since humans sort of made these decisions and got us into this state of being, this fragile place, humans certainly have the ingenuity to get us out of this situation. These are the pieces that we can control. We can control how much water gets to the lake. I think as a kid, when I was splashing around in the water around the islands of North Carolina, I was always staring down and looking under rocks and looking for things that were alive and looking for colors and thinking about what the ecosystem had to tell me. And I think that's still the way that I see science. And when I'm at Great Salt Lake, I am looking below the surface. I am looking at the bottom of the lake, and I'm thinking about what is going on that is supporting this system. And we all know that photosynthesis is this process that brings in sun's energy to every system. So if you're on the ground, it's the plants that are doing photosynthesis. But if you're in the water, it's the algae and these ancient cyanobacteria that have been on Earth for 3.5 billion years. And cyanobacteria actually crawled inside bigger cells and made algae and plants. So they are absolutely cool. And one of the things they do is they form mats. They stick to each other. They form this sticky goo called extrapolymeric substance, which is a terrible science word. I like sticky goo. So they form this sticky goo, and that sticky goo starts to collect granules of minerals, and it pulls them together and makes a rock. And so I study something called microbial ite. And ite means it's a rock, like a meteorite. means it's a rock, and microbial means that microbes made it. So they're literally rocks made by microbes. And these mats live within all of these minerals, and they grow towards the sun. So they become like mound shape because they're trying to get sunlight. And they live in the margins of the lake, the really shallow part that's near the shore. So when we started looking at these, we wanted to understand who is eating these and how are they working for Great Salt Lake. So we first noticed that the brine shrimp were eating the algae in the water column. So the brine shrimp swim by and they just eat the little algae that are floating around the water column. But who's diving to the bottom and eating on these microbialites? Because that's different to go to the bottom of the lake. And it turns out that the brine flies, they have larvae that live in the lake, like little caterpillars, and they go to the bottom of the lake and they munch on these little microbial mats. And then when they get full up with all the food, they form a pupa, like a little cocoon on the bottom of the lake. And without these mounds, these flies would have nowhere to latch their pupa onto. So it provides both habitat and food. And so I think the microbialites feed the brine fly food chain, if you will, and the algae in the water feed the brine shrimp food chain. So I've been really diving into what these microbes are doing for the system. And as the lake shrinks, what happens is the water gets saltier. So yes, there's less water and the shorelines get bigger because the water is less, but only water evaporates. Think about the water cycle. Only water evaporates. The salts get left behind. And so the water becomes saltier and saltier and saltier. And the question I have is, when is it too salty for those algae and those cyanobacteria living in the mats? And what we're finding in our lab is that we've reached that point where it's too salty for these microbes that form the foundation of the system. And these microbes are starting to die or slow down their division. And so we're really close to a point where both food chains are going to struggle in the lake because the food itself is going to become extinct. And so we really have to think about how to dilute this water, how to get more water to the lake, how to make it less salty. And so I'm interested in questions like, what is too salty for the microbes? And if they get too salty and they start to die, can you bring them back to life by making it less salty? So that's an experiment we're doing in my lab right now. And I think that's an excellent question. The other thing is, well, what if the lake shrinks and leaves these microbialites on the beach and they dry out? Could we do that in the lab? Could we dry them out and then put water over them again and try to bring them back to life? Are they resilient? You know, do they respond? Are they used to drying out and getting too salty and then getting rehydrated later? So these are some kind of cool questions that we're throwing around that I think relate to the actual system and what's happening in the whole environment. So that's kind of a fun place to play right now, and it's a very relevant place to work on this system.
Great Salt Lake, the largest saltwater lake in the Western Hemisphere and the 8th largest freestanding lake in the world. But what used to be a boater's paradise and a safe haven for wildlife is now a looming ecological disaster. Climatologists blaming unrelenting high temperatures and a record western drought made more severe by climate change being blamed for the lowest water level ever seen in Utah's Great Salt Lake. The lake now just 1/3 its usual size and shrinking weekly.
It's so different when it's quiet out there. It's like a cemetery. Because it used to be so full of life. Brine flies are just the cutest creatures because they don't bite you. But they would be there in these numbers of the millions, I would say, just millions of them on the shore. And when you walked through them, these swarms, these mermations would just like go around your feet. And it was the coolest thing to watch them. I used to try to get videos of my feet walking through the flies and disturbing their flight. And if you watch shorebirds, particularly gulls, what you'll see them do, these lazy birds, is they will just run through a swarm of brine flies with their mouth open, just like free food, right? And I always loved watching them. I even made up maybe a little bit of a dance to like mimic what they were doing that we used to do with our students. So I think that not having the brine flies present, it changes the whole sound and feel of the shoreline. And, the shore doesn't even have that briny smell that it used to have. You can just tell that something is different and it's quiet and it's wrong. The shorebirds aren't on the shore because there's no flies. So they're having to try to find other places to eat. It's probably the most important body of water for migrating birds on the whole Pacific Flyway. If you talk about from Canada, and for some birds, even the Arctic, flying all the way down to Mexico or South America, and some birds only fly as far as California, there's different routes, but all of them have in common Great Salt Lake and feeding at Great Salt Lake, and how important that is to build their muscle so that they can engage in the flight that they need to make those long journeys. If Great Salt Lake continues to shrink and the shrimp and the flies struggle, we are at risk of harming the migratory routes of 10 million birds. That's a lot of birds. So 338 species of birds migrate here and depend on Great Salt Lake. And we need to take that seriously. This is an important body of water. And where are they going to go? Because other bodies of water are either smaller, or there are even smaller salt lakes that are shrinking as well as our lake. So we really need to care for this resource. And I think that's, one reason to care is the ecosystem. Another reason to care is human health, because there are heavy metals in this body of water that have come from mining. For example, gold mining in Nevada in the 1800s through the early 1900s. One of the byproducts is atmospheric mercury, and it floated right over Great Salt Lake, which has all of these sodium and chloride ions, and the chloride ions lift up above the lake. And if they bind with mercury, they form mercury chloride and it falls into the water. So we get what scientists call atmospheric deposition, where it deposits from the atmosphere. And that mercury in the lake can then be changed into a form that is easily taken up by biology. So we worry about mercury, and that's where the mercury probably came from. We worry about arsenic, and it is a normal, average, everyday part of our environment here in Utah. So the Ochre Mountains have high levels of arsenic naturally, and that arsenic is certainly in the lake bed. And so that is a heavy metal that is dangerous for human health that just happens to be in the soil already. We also have selenium, and that's a byproduct of copper mining. So that's an example of 3 heavy metals that are in the lake water that, they're at levels that we don't worry too much about because they're in the water. Now, if the lake shrinks, the area that was the lake bed becomes a dusty salt playa, and that can form dust that can blow into the valley. And that's not just dust, that's not just particulate pollution, because it could also have those heavy metals. So we're concerned about heavy metals in the dust. We know these aren't good for human health. We're not drinking Great Salt Lake water, so we're not worried about getting it from the water, but the dust and entering our respiratory tracts could be quite a concern. We're very, very worried about that. So for people who tell me, well, I'm not a bird watcher, I don't really care about the birds of the lake, I always say to them, but you breathe, right? And so you really should care about air quality and getting good air to the people of Utah. And so I think that's another reason to make sure that we continue to work towards getting more water to the lake.